Back everyone to my channel. In this video we're going to see one of the important derivation from chapter 9 class 12 ray optics, that is how to we get the expression for the refractive index of the material of the prism in terms of angle of prism and the angle of minimum deviation. So to obtain this expression, first we have to draw a prism. Okay, so first let's draw prism. Okay, if we draw prism and if we name it A, B and C, A is the angle of prism and BC is the base of the prism. So we have got now angle of a prism. Then angle of minimum deviation. What do we mean by angle of minimum deviation? It is the angle of incidence and the angle of emergence both are equal. Then the angle of refraction is, like refracted ray is parallel to the base of the prism, that is BC. So first we have to draw a angle of incidence. So as soon as we draw a ray, we have to draw a normal which is exactly perpendicular to this AB. Okay, surface. We have drawn a normal here. Okay, so this incident ray is PQ and angle of incidence, then refracted ray QR. Here also we have to draw a normal which is exactly perpendicular to this AC. So we are drawing a normal here and these two intersect at a point. Let's call it as N, and this is the first refraction. This is R2. Then there's an emergent ray which is RS. Okay, then angle of emergent is angle of emergent E. Okay, then I is the angle of incidence, R1 R2 are the angle of refraction, E is the angle of emergent. Then now if we extend this incident ray, if we extend this incident ray and the emergent ray, they form an angle which is the angle of deviation. Okay, so first we have to consider a triangle QNR. So first if we consider a triangle QNR, so if you just draw so much is more than enough, and for your to make it so clear, you can do this in the working column and not in the derivation. Okay, so QNR, Q is R1, R is R2 and N we don't know. So we know some of the angles in the triangle is 180. So in triangle QNR, so R1 plus R2 plus angle QNR is 180 degree. So we don't know QNR, just keep QNR one side and the remaining on the other side. So it is 180 minus R1 plus R2. Okay, this minus is for both R1 and R2. This is the first expression we have obtained. And then we can see a rhombus here, AQNR. Okay, so in rhombus AQNR, we know the sum of the opposite sides in the rhombus is 180 degree. Okay, so by applying that, we need to get the expression in the form of angle of a prism. So we'll take A and N. So angle A plus angle N or QNR is also okay, which is equal to 180 degree. We know angle QNR. So substituting the QNR value in this, we get angle A plus 180 minus of R1 plus R2 is equal to 180 degree. This 180 both gets cancelled. Angle A is equal to, if this whole goes on the other side, minus changes to plus, so R1 plus R2. We have got the expression for the angle of prism. So this is the equation number 2. Okay, now the total deviation, the total deviation is the sum of deviation at two surface. Okay, deviation at the two surface. Okay, so the total deviation here is I minus R1 plus here E minus R2. Okay, E minus R2. This is deviation number at the surface 1, deviation at the surface 2. Okay, so deviation is I minus R1 plus E minus R2. So I plus E, this R1 and R2 will take at the same place. So like R1 minus R2, if we take minus common, deviation is equal to I plus E minus of R1 plus R2. Okay, this R1 plus R2 is equal to angle A, that is angle of prism. So on substituting the value of R1 plus R2 in equation 3, okay, on substituting equation 2 in equation 3, we get deviation is equal to I plus E minus A. Okay, this is the expression number 4 we get. Okay, and as I have told before, what is angle of minimum deviation? The angle of incidence and angle of emergence both are equal. Then the refracted ray is parallel to the base of the prism. So that we have to write at minimum deviation, the refracted ray inside the prism is parallel to the base of the prism. So it just means at minimum deviation, let's say minimum deviation as D, okay, capital D. At minimum deviation D, the deviation will be equal to D, as I've told it. Then the refracted ray like R1 and R2 will be equal to R, and angle of incidence and angle of emergence both remains the same, like both will get equal. Okay, so if we substitute the values in the equations what we have obtained in the equation number 2, okay, so now equation 2 and 4 will become as, equation 2 is actually angle A is equal to R1 plus R2. So A is equal to R plus R, so A will become 2R. Okay, then angle of refraction, like refracted ray, angle of refraction is A by 2. This is one of the equation we get. This is 5, and the equation number 4 is actually deviation is I plus E minus A, and this is actually D, I plus I, so we just take I plus I minus A. Okay, then A is actually 2R. D is equal to 2I minus A, so we need I, angle of incidence. Then A we take on the other side, D plus A is equal to I is equal to D plus A divided by 2. This is equation number 6. Okay, we have obtained the angle of refraction and angle of incidence. Now we know a law of refractions. There are two laws of refractions. In that we have to take Snell's law. Snell's law is just N1 sin I is equal to N2 sin R. Okay, we have to obtain in the terms of refractive index, angle of prism, angle of minimum deviation. So N1, N2, those are the representation of the refractive index. So N21 is equal to, that is N21 in sense N2 by N1. If it is N2 by N1, N1 goes the side, so sin R comes the side. So sin I by sin R. We have to now substitute the value of I and R as we obtained it before, equation number 5 and 6. So N21 is equal to sin I is A plus D by 2 divided by sin A by 2. This is the equation for the refractive index of the material of the prism in terms of angle of prism and angle of minimum deviation. Thank you for watching.